Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 3, Section 7, Slopes of Parallel and Perpendicular Lines. We normally teach these Sections 6 and 7 together because Section 7 is so short, and it also involves a lot of Section 6 material. So it'll be a short video, and then I want to do one example to show you how we're going to use this. Okay, so first we have slopes of parallel lines. Two non-vertical lines are parallel if and only if their slopes are equal. Okay. The reason why we have to have non-vertical lines in this is because vertical lines, the slope is undefined. So we can't say an undefined slope is equal to an undefined slope. So what we do is we'd say two non-vertical lines are parallel if and only if their slopes are equal. And then we say all vertical lines are parallel. So if we have any two vertical lines, they are automatically parallel. So the example, if I want to check to see if these lines are parallel, then I need to find the slope. So the slope of L1 is that line on the left. So it's going to be subtract the y's, so 5 minus -4, 5 plus 4. And then 1 minus -2, so 1 plus 2 is 9/3 or 3. And the slope of L2 is going to be 3 minus -4, so 3 plus 4, and then 3 minus 1, so 7/2. And if you take a look at these slopes, they're not the same, so they are not parallel. So we can write this as L1 is not parallel to L2, and our reason is the slopes are not the same. And then we also have perpendicular lines. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So again, we have a special case for vertical lines because of that undefined. Any vertical and horizontal lines are perpendicular. Okay? So vertical would be undefined, horizontal would have a slope of 0, and so we can't talk about the product of undefined and 0, so we have a special case for them. But any two lines in which neither one of them is vertical are perpendicular if the product of their slopes is -1. Now, a lot of you learned this as they must either be negative reciprocals of each other, or sometimes we'll call it opposite reciprocals. And that's fine for determining if lines are perpendicular. You can use that. Okay. So, for example, if I had y equals 1/3 x plus whatever, I'll call it 10. If I had a perpendicular line, its slope would have to be the opposite and reciprocal. So it would have to be a -3/1 or 3. And then the y-intercept could be whatever. If you take those two slopes and do the product, you get 1/3 times -3, which is -3/3, which is -1. Check. They are opposite reciprocals. Now I can show that this works for any two lines that have an opposite reciprocal. So if I say y equals, how about a/bx plus c? Now the second line couldn't just be like d/e, it would have to be the opposite and then reciprocal. And then whatever. If I multiply these slopes together, I get a/b times -b/a, and so that becomes -ab/ab. And if you divide out the like factors, you end up getting -1. So anytime the slopes are opposite reciprocals, what we're going to get is the product of the slopes is going to be -1. Okay. So let me just show you one example where we might use this. So suppose we want to write a point, or write an equation. And let's have it go through the point -1, 5. And let's have it be perpendicular to y equals 4x plus 1. And let's make it in standard form. Okay, so they give us a lot of material, and some of this is extra material that we don't need. In order to write an equation of a line, two things I need. I need a slope and I need a point. So if I take a look at this, there's my point. Now all I need is a slope. Well, they gave me an equation that I know my line is perpendicular to. So what I'm going to do is I'm going to take the slope out of that line, and then I'm just going to find the perpendicular slope. So opposite reciprocal of 4 is -1/4. And now I have my slope. Okay, so now I have my point and I have a slope. So my equation is y minus my y coordinate equals my slope, x minus my x coordinate, so +1. Okay. And now if I only had to write an equation, this would be done, but I want standard form. So what I would get rid of first is get rid of the 1/4, or actually I get rid of the 4 in the denominator. So what I'm going to do is I'm going to multiply both sides of this equation by 4. On the left, you got to remember to distribute, so 4y minus 20. Now on the right, because you can do the 4 times -1/4, because it's all factors, it's 4 times -1/4 times the quantity x plus 1. You can multiply the 4 times the -1/4, and then what's left can distribute into the x plus 1. So 4 times the -1/4 is -1, and then you still have x plus 1. And now what I'm going to do next is I'm going to distribute that -1. So -x minus 1. Now I'm going to move the x to join y, so x plus 4y. And I'm going to add the 20, so he's going to come join the other side, and he's going to become 19. And I am done. This is my standard form. That's it for today's video. Thank you for watching. Have a great day. Take care.